Suppose you have extended object like this. You want to find the center of mass of this. By the way, in engineering, they call it centroid. And it's a very extensive subject. Again, we put a coordinate system on this. X is x of center of mass, and there's y center of mass. How do we find that? We divide this into small pieces, that each piece becomes like a particle. And it has a mass dm. And multiply that mass by its x coordinate, and add them all together, and divide the total by the total mass. So when you have extended object like x of center of mass or centroid, they usually call it x bar in engineering. In physics, we just call it xcm. In engineering, they call it x bar. They call it centroid. And it's defined as 1 over total mass, if the whole mass of this is m, times integral of x times dm. Like you see it, each mass is multiplied by its x and added together, right? So the mass is dm at the x position x and added together. And y center of mass the same way. 1 over m integral y dm. And how do we use that? Let me just apply to something uniform like this. If something is uniform and has uniform mass density, the center of mass is the same as its geometrical center. How do we get that? Let's apply this formula simply to that situation. Let's say we have this ruler extend from 0 to L. And we put a coordinate system here, x and y. We ignore the thickness of it. And let's take a small piece here. Let's say it has a length dx and has a mass dm. It has a mass dm, has length dx. And now I want to find the x of center of mass. Total mass is m. How much is dm? Let's find dm in terms of dx. Can I say that dm over dx equals total mass over length, total length, because it's uniformly distributed mass, right? Mass is uniformly distributed, so dm over dx is proportional to m over L. Mass over length, mass over length. The mass is proportional to length. So dm is over L times dx. Right? And then we put everything in here. X. X of center of mass is 1 over n times x dm, integral x times dm, which is m over L dx, right? And the integral goes from 0 to F. From the beginning is at 0, end is at L, right? So this is the extent of x that move. And m over L comes out. This m cancels out, x of center of mass. M cancels out, we get 1 over L, integral 0 to L, x dx. What is integral x dx?
X squared over 2.
X squared over 2. So it's 1 over L, then x squared over 2, evaluated between 0 and L. Then you evaluate that between 0 and L, you put L, becomes L squared, divided by 2 minus 0, right? So it becomes L squared divided by 2L. X of center of mass becomes L squared divided by 2L. So one of the L's cancels, 1 over L over 2. Becomes at the center, right? So when something is uniform, the center of mass is at its geometrical center. And also center of gravity, sometimes they talk about center of gravity instead of center of mass. Center of gravity is the average of gravity. It's like a point where all the gravity seems to be applying. You can define the same way the center of gravity When you are on the surface of the Earth, the gravitational field is uniform. X of center of gravity is equal to 1 over total weight integral of x dw. This is weight, right? The total weight is total mass times g, right? So let's say x of center of gravity is 1 over mg integral of x dw, x, and dw is g times dm, g dm. And then this g comes out, cancels with this. So it becomes 1 over m integral of x dm. Right? It becomes the same as center of mass. X of center of mass. Center of gravity and center of mass are the same if you are in a uniform gravitational field, like on the surface of the Earth. Now you see, this is a meter. If I want to find a place where the gravity seems to be applying from there, I just balance it with one force, right? I just apply one force instead of all these little forces that Earth applies to everywhere. I apply one force at the center, I cancel all of it. It means that all of these forces seem to be applying to this point downward. And I'm applying the opposite force, and everything is in equilibrium. Right? So that becomes center of gravity. We have a standard mass here. I want to put that here somewhere and find the new center of gravity or center of mass. Using that place of center of mass, I want to find how much is the mass of this ruler. Okay? Suppose I don't know the mass of the ruler, but I can measure it. I didn't yet. This is the standard mass is 100 grams. And if I balance it here on this, it's supposed to be at 50 centimeters, but because it is wood, it's supposed to be uniform, but wood has some concentration variation, right? Or density variation. It's a little bit off. Instead of 50 centimeters, actually I see that it is about 49.7 centimeter, right? It's not exactly at the center. So the whole gravity of this seems to be applying at this point, therefore center of mass is also there. Center of mass of this whole thing is at 49.7, all right? 49.7 centimeters. And now, I want to put this standard mass somewhere. You pick a number from 2 to 20.
14.
14. I put that at 14 centimeter mark. So it's 10, 14. So of course it is a little bit hard to do that. But then with this at 14 centimeter, I find new center of mass of the whole system and see where it balances. Now it doesn't balance at 50 centimeter or 49.7. It balances at a new point like this. It's about 35.4. It's hard to read with that accuracy, but 35.4, I think it's pretty good measure. This is the new point. So 35.4, remember that, okay? We have three numbers. Where was it at the beginning? 49.7, right? Let me write this down. Let me put the coordinate system here. Start from the beginning of the ruler, and I put x-axis here, y-axis here, and the center of mass of the ruler itself, or meter stick, instead of at 50 centimeter, was at 49 centimeter. And I put the 100 gram at 14 centimeter. So this was 14 centimeter. And then it balanced at, what did they say? 35.4? 35.4? 35.4, right? Like around here. And I know this is 100 grams. I don't know the mass of this one. And I know the center of mass is here. So I can set up this equation and find the mass of the second object. So if I write everything in grams and centimeter, it will be fine. So excess central mass was 35.4. 35.4 equal to M1. Let's call this number 1, this is number 2. And I want to find the M2, right? So M1 is 100 grams, so 100 times 14 centimeter, plus M2, which I want to find, times 49.7, divided by 100 plus M2. And now cross multiply, you can solve for M2, right? 49.7 M2, right? And then move this over, you get 3540 minus 1400 is what? You get 21, right?
2140.
40 equal to the difference of these two, M2 times 49.7 minus 35.4.
14.3.
14.3. So M2 is 2140 divided by 14.3. How much is that?
150.
150 exactly?
No, 149.65.
Okay, I hope that's correct. All right, let's see. Let's measure. Here, it is 100.1 grams, so that's the error, 100.1. And this one, 149.3.
What? That's crazy.
I thought something was wrong. I didn't know. 149.4. How much was that? 149.65.
0.65.
By how much is it off?
Like point nothing.
Point nothing.
All right, so it seems to work, right? If you don't have a scale, you want to measure something that is like that, you can do it, right? All right.